Many engineering workflows now involve running 4 or 5 agents at once, a coding agent in one terminal and a search model in another. Working between them is a manual process. You copy text from a terminal, paste it into your docs, and feed it to another chat. This friction exists because models are wrapped inside software called an agent harness. The harness is the specific tool that gives an underlying model its capabilities. Because these harnesses use different interfaces, they are essentially silos. They cannot communicate or collaborate with one another. In this environment, the primary bottleneck isn't the intelligence of the models themselves, but the isolated architecture that keeps them from working together. Databricks solved a similar architectural problem a decade ago. The challenge was taking fragmented servers and data silos and organizing them into unified, distributed computing platforms. By applying that same engineering philosophy to AI, we can move the focus from organizing distributed compute to organizing distributed intelligence. This historical blueprint for managing massive data systems provides the exact structural framework needed to fix the broken AI workflows we see today. This is why we built Omnigent. Omnigent is a meta-harness. It provides an abstraction layer that sits physically above your existing agent tools to bridge the gaps between them. This architecture uses a unified API for composition, allowing developers to mix different harnesses and models in a single environment. With this layer in place, you can swap between Claude Code, Codex, or your own custom agents with a one-line code change. This enables you to design loops where teams of sub-agents work in parallel on a single complex task. Interoperability ensures that your development process is no longer limited by the hard boundaries of any single model's interface. Omnigent also introduces a structural change to control. We've replaced flimsy text prompts with dynamic, stateful policies housed directly in the meta-harness. These policies can automatically pause an agent once it reaches a specific cost budget, or require human approval before a code push is allowed. The system uses a strict OS sandbox to physically intercept unauthorized network requests or system access, providing a level of security that prompts alone cannot achieve. To solve the copy-paste problem, we added collaboration features. You can now share live agent sessions with teammates via a URL, letting multiple people steer an agent in real time. Managing teams of autonomous agents is only viable if humans have a reliable, centralized layer to govern them. We are seeing a shift similar to the move from managing individual servers to managing massive server fleets via Kubernetes. Software engineering is moving past prompting single bots and towards orchestrating entire teams of distributed AI. While models and individual harnesses will evolve, this overarching meta layer provides a stable foundation that stays with the developer. We believe this layer should be open to everyone. Omnigent is available today as an open-source project under the Apache 2.0 license. The era of isolated, manual AI workflows is over. You can find the repo on GitHub and start building the future of distributed intelligence right now.